All right, so we're going to take a look at this more complex example. Complex because it's a rational expression, which are always fun. So, same rule, we need to find the second derivative, so most of the work is going to come from getting that second derivative to begin with. All right, so we're going to say that f prime will be low d high minus high d low over low low. All right, and I need room, so I'm going to get rid of my face. Boom. Okay. So from here, we can simplify this, and we get 2x cubed minus 8x minus 2x cubed minus 2x over x squared minus 4 squared. And we can see that the 2x cubes cancel out. So then we are free to say that the first derivative of this equation function should be a negative 10x over x squared minus 4 squared. So that's what we got. Now we need to go ahead and take that and find the second derivative. So I am going to be strategic. I am not going to expand the denominator. I'm going to choose to do the chain rule. And hopefully you'll see why I'm choosing to do so. So for the second derivative, it's low d high minus high d low. All of that is over low low. All right. So just a quick heads up. This is the derivative of the denominator when you do the chain rule. So now let me show you why I chose not to expand the denominator of the first derivative. So here's what you may notice. I can pull out a greatest common factor in the numerator. And that greatest common factor can be a all right, well, let's just start small. All right. I see that they both have an x squared. Oh, sorry, the denominator should be to the fourth, not squared. My apologies. I see I can pull out this from the numerator. X squared minus 4. Right? X squared minus 4, x squared minus 4. But I only pull one out because that's a squared and this is technically to the first, so I always take the lower power. You might be asking yourself, Mr. Rodriguez, why didn't you mess with that 10? Because you see that 10 they both have in common. But I'll do that in a little bit because I want to do this step by step in a way that makes sense to you. All right, so that means I would have an x squared minus 4 multiplied by a negative 10 minus a negative 10, so that's going to be positive. So 10 times 2 times 10 will be a 40 x squared. And that is my numerator over x squared minus 4 to the fourth. And now you can see why I chose not to do that, why I forced myself to go through the chain rule, because I can easily see that this will take out one of these and bring this down to a third power for me. And inside the brackets, I have a, so I have a negative 10x squared plus a 40 plus a 40x squared, right? And that is now currently over the x squared minus 4 to the third. So then I can say that I have, well, this is really just going to, this and this will give me a 30x squared plus 40. So now I'm going to choose to do my factoring. I'm going to choose to do a positive 10 because now I see that's the easiest way to do it. So I'll have this left over for my second derivative. All right, and if you're asking yourselves, Mr. Rodriguez, why and how would you think to do that? I didn't. I spent 7 minutes trying to do it the other way where I expanded the denominator, realized what a terrible mistake that was, and went back and did it this way instead. So yeah, it was just a, I don't know. The other way I did it didn't work. I wasted my time, and that's okay because I came across this way now. So if this is now my second derivative, I need to go ahead and do some interpretation. I need to locate the values of x where f of x is, or I'm sorry, f double prime is equal to 0 or f double prime does not exist. So that is code for set this equal to 0 to figure out where the second derivative would equal 0. Set the denominator equal to 0 to figure out where the second derivative does not exist. That's D. Okay, so if I look at the numerator, right, I'm trying to figure out where 10 times this equals 0, and that's positive. This will always be positive. Positive multiplying by another positive will never equal 0, so this one has no solution for where the second derivative would equal 0. However, the denominator, I can easily tell you where x squared minus 4 cubed would equal 0. Right? Because essentially asking you where x squared minus 4 would equal 0, which I know to be at positive and negative 2. Okay. So that means when I set up my number line, good enough. I know I have positive and negative 2 as a way to set up my intervals now. Okay, and I'm going to put, UD just for the undefined parts. Because that, I mean, you can go back to the original problem and denote that these are actually going to be vertical asymptotes. So let's go from there. All right. So test out a number over here, negative 3. So like I said before, if we look at the second derivative, the numerator will always be a positive number no matter what I have because I'm squaring it. So automatically multiplying a negative by a negative makes it positive. Adding 4 makes it positive. Multiplying by a 10 keeps it positive. So the numerator is always positive. However, the denominator, x squared minus 4 raised to the third, when I replace the x with a negative 3, well, negative 3 squared will be a positive number. 9 minus, and that's going to be bigger than 4. So that's going to produce a positive. So positive divided by positive stays positive. I'm feeling lazy, so I'm going to use 0 because I can. Numerator is going to be a positive number. The denominator is going to be, let's see, 0 minus 4 is going to be negative. So third power stays negative. Positive divided by negative is negative. And if I look at 3, well, 3 will play out kind of the same way because 3 squared is the same as negative 3 squared. So I will still get a positive number in the denominator, so I get positive overall. So now I'm ready to say that I'm ready to figure out the intervals. And here's how it goes. From negative infinity all the way to negative 3, or from 3 to positive infinity, f of x is concave up. And between negative 3 and positive 3, f of x is concave down. So all you have to do is make sure that when you're doing this, you're just super careful finding your derivatives, because plugging in numbers isn't the difficult part. Analyzing it shouldn't be the difficult part if you understood last week. It's being careful and not making those little itty bitty mistakes. So if you want, I'll be available on Monday during office hours for Zoom if you guys just want to. Oh, actually, we have to meet live on Monday anyways. If you guys want to stick around after I give you a little synopsis of what we're doing, yeah, just work through this with me. Make sure you avoid any little mistakes, and you should be good to go. Have a good weekend, or hope you had a good weekend, depending on whenever you're seeing this.